Hi, welcome to T1 Academy. In our last session, we have finished our profit and loss concept. So today in this session, we are going to start discussing about the ratios and proportions. So as I have already told you, these three concepts, percentages, ratio and proportions, these two are mostly the basics for some other concepts. See, if you see the percentage concept, we are going to use that percentage in profit and loss, simple interest, compound interest and some other areas. When it comes to this ratio and proportions, we will use this ratio and proportions in our partnership case. We are going to use this in ages. We are going to use the same thing in our DI also. So this ratio and proportions is very important for us. This is one of the basic concept which we should know definitely. By learning this concept, we can easily solve the questions from partnerships, averages, ages, all those things we can easily solve them. Okay, now we will see the concepts of this ratios. Right? Now, what is this ratios? See here, to express any two numbers, if I want to hide the values, I will use the word, this one, that is ratio. That means, for example, if I want to express or if I want to tell the relation between two persons without telling exactly their values, then I can say that two numbers are in the ratio of 2:3. I don't want to reveal their number or exact value, but I want to tell the relation between them. Then I can take the help of ratios as well as percentages. Okay, but in our case, ratios, if I say that two numbers are in the ratio of 2:3, it can be any value, but person A and B, if A is to B is some 2:3. If person A is of two parts, B will become how many parts? 3 parts. But we don't know the exact value. It can be 2, 3, 4, 6, 200, 300, 2000, 3000 or 2 lakhs, 3 lakhs, whatever it may be. But the relation between them will be in 2:3 ratio. 2:3 ratio. That means, see here, ratio is strictly a mathematical term to compare two similar quantities expressed in the same units. That means I cannot compare two different quantities. Okay, definitely I can compare only the similar quantities and then only I can tell my ratio between two persons. See, similar quantities and different quantities means, see here, if there is income of a person, I can write the ratio between the incomes of two persons. But I cannot write the ratio between income of one person and the savings of the second person. So either I can write the ratio between their incomes or I can write the ratio between their savings. But I cannot write a combined ratio of income and savings. That is the meaning of this similar quantities. Similar quantities in the sense I can only write the relation between the similar quantities, not two different quantities. Understood? That is the regarding these ratios. Now next, the same thing. In general, the ratio of two quantities A and B is written in the form of A:B. We all know it in general. And we read it as A:B. The two quantities A and B are called terms of the ratio. First quantity A is called as antecedent or first term, and the second quantity B is called as consequent or the second term. Okay, consequent or the second term. Now example, in a mathematical class, there are 16 boys and 20 girls. Find the ratio of number of boys to the number of girls. This is my question here. So what happens here? Boys is to girls. How many boys are there for me? 16 boys. And how many girls are there for me? 20. Okay, so that means cancel them. 4:5. With what table I have cancelled here? 4 table. With 4 table, 4:5. Now please observe here, students. When it comes to these ratios, we should know some of the basic concepts like this. See here, ratios, we should understand some important properties of these ratios. What are those important properties means? First and foremost thing, ratios will be always in a simplified form. Simplified form. That means the ratio should be always in a simplified form. For example, if I have something like this, some 20:40. I can cancel it with 2 table. I will write it as 10:20. Right? See here, students, I can further simplify it, right? I can further simplify it, right? Why? Because I can further cancel with 5 table. 5 2s, 5 4s, and next 2 1s, 2 4s. Sorry, 2 2s. So at last, what I can write the answer as 1:2. So the ratio should be, whenever you write ratio between two numbers, it should be always in a simplified form. I cannot leave, sir, 20 is to 40 is also equal to 10 is to 20. Why I cannot write? No, you cannot write this one. Why? Because we should write in the most simplified form as our answer. Always, while you are writing the answer, definitely it should be most simplified form. In some cases, we only make it in different matters. That is secondary. But in general, ratio should be in the most simplified form for us. Okay, good. Ratio should be in most simplified form. That is one property for us. Next one, the second property of this is we can multiply or divide a constant to any ratio. Okay, based on our requirement, in some cases we will multiply or divide a constant to our ratio. For example, see here, I have a ratio something in this manner, 2 is to 3. 2 is to 3. Now, what I can do is, if it is required, there will be some situations where we need to change the ratios. In that cases, we will sometimes multiply the things, sometimes we will divide the things. Okay, now multiply in the sense, if I multiply it with 2, for example, a constant 2, what happens to its value? 4 is to 6. 4 is to 6. Will the proportion or the ratio changes here? Anyway, if I further cancel it, it will come back to 2 is to 3 only. 2 is to 3 only, right? So, that means I can multiply anything to a ratio. There is no wrong in that. And similarly, I can divide anything to a ratio. For example, if there is something like this, 2 is to 3, if I divide it with 3, what happens to this, students? If you observe carefully, this becomes 2 by 3 is to 3 by 3. 2 by 3 is to 3 by 3. So now, what happens to this value? 3 anyway will get cancelled, and finally we will get the same answer, 2 is to 3. That means you can multiply or divide anything to a ratio. It will not affect our given portions. It will not affect our given relations. The relation between A and B remains the same, whether you multiply or divide any constant to a ratio. That means based on our requirement, sometimes while solving the problems also, we are going to multiply or divide a constant to the given ratios. Okay, why? Because we will later do the same thing. So this property we will apply there. Okay, we can multiply or divide a constant to any ratio based on the requirement. Based on the requirement, I can do that one. Okay, that is the next property. We can multiply or divide constant to a any ratio. And next one, we cannot, remember this one, we cannot add or subtract a constant to a ratio. We cannot add or subtract. What is meant by this add or subtract means, see here, if I have something like this, 2 is to 3. I cannot add a constant to them. That means I cannot say that I will add plus 1 to this and I will write it as 2 plus 1 is 3 and 3 plus 1 is 4. Now, can I restore it back to my original ratio? Is it possible? No, it is not possible. So, you cannot add or subtract, and similarly with subtraction also. You cannot add or subtract a constant to a ratio, but you can multiply or divide a constant to any given ratio. So, try to understand the difference between multiplication and this addition. We will not do the addition. And next observation is, while writing two ratios in the form of two numbers in the form of ratios, while writing two numbers in the form of ratios, we cancel them with their HCF. While discussing the LCM and HCF also, we came across these things, students. Okay, while discussing LCM and HCF also, we came across the same thing. So, while writing two numbers in the form of ratio, take for example, if I want to write the ratio between 15 and 18. If I want to write the ratio between 15 and 18, with what table I can cancel 15 and 18? With the 3 table. 3 5s, 3 6. So, that means what happens to its value? It becomes 5 is to 6. But if you observe carefully, with what table I have cancelled it? With the number 3. If you observe carefully, 3 is the HCF of 15 and 18. 3 is the HCF of 15 and 18. For example, if there are two numbers something like this, 20 and 40. If I want to cancel 21s, 22s. So that means what I can write finally this value as 1:2. Now please observe what is 20 for 20 and 40. 20 is nothing but the HCF of 20 and 40. Okay, HCF of 20 and 40. So that means while writing two numbers in the form of ratios, we always cancel them with their what? With their HCF. That is the concept we have here. Okay, next at the same time, if you observe carefully, okay, while if any two numbers are in the ratio of some 3:4, right? If for example, if two numbers are in the ratio of 3:4, generally what we will do, we will write them as 3x and 4x, right? We will consider them as 3x and 4x. If you observe carefully, what about this x means? This x is nothing but the HCF. This x is nothing but the HCF of these two numbers. HCF of these two numbers. Okay, understood? So this x, that is the HCF. That is the HCF. Okay, next one. If two numbers are in the ratio of 3:4, then what we can call it as, this 3 we call it as 3 parts, and this 4 we call it as 4 parts. 3 parts and 4 parts. 3 parts and 4 parts. Now if you observe carefully, assume that the ratio between A is to B is 3:4. 3:4. If I want to write the value of A is how many parts in this total equation? A is 3 parts. Out of total, how many parts are there for me? 3 plus 4, 7 parts. 7 parts. A's portion will be equal to 3 parts out of 7 parts. So 3 and sum of these two is 7 parts. When it comes to B's portion will become what for me here? B is 4 parts out of total 7 parts. B is 4 parts out of total 7 parts. So A is 3 out of 7 parts and B is 4 out of 7 parts. In this manner, we are going to solve the problems and try to understand the things here. Okay, understood? Now, next, while solving the problems, if you observe carefully, we will come across certain things. What are those certain things means? Usually, the ratios will not be of the form P by Q. In general, the ratios will not be of the form P by Q, but what will happen for us in this case is, for example, if two numbers are in the ratio of some 1/2:1/3. 1/2:1/3. Then if I want to write it in the normal form, general form, instead of this P by Q form, so what I will do is, I will take the LCM of denominators. What is the LCM of 2 and 3 for me here? 6. And we have one property of this ratios, what? We can multiply a constant to a ratio. There is no wrong in that, it will not affect our ratio. So because of that reason, I will multiply this ratio with 6. That means what happens to this? 1/2 into 6 is to 1/3 into 6. Okay. Now what happens to this? 3 and 2. So the ratio becomes what for me here? 3:2. The ratio here becomes 3:2. Both 1/2:3 or 3:2, both are same. There will be no difference between these two things. Understood? Generally, if you have anything in the form of P by Q, the ratios are in the form of P by Q, then what we are going to do is, we will take the LCM of denominators. And after taking the LCM of denominators, we will multiply it with the ratio. Why? Because we can multiply a constant to a ratio, it will not affect our given ratio. That is the thing which we have done here. Like this, we have some traditionally asked questions from these ratios. What are those means? Please see here. Duplicate ratio. Duplicate ratio means nothing but squares. That means if I want to write the duplicate ratio of some 2:3, then the duplicate ratio will become 2 square is to 3 square, which will become 4:9. Understood? Duplicate ratio means squaring of the ratios directly. Next, triplicate ratio means similarly cubing of the ratios. 2:3, if I want to write the triplicate ratio means 2 cube is to 3 cube. That will become what for me? 8:27. We call that as triplicate ratio. In some examinations, they may ask us directly from this area. Okay, just remember the values. Duplicate means x square and y square. Triplicate means x cube and y cube. Next, subduplicate means what? Square root of root x is to root y. For example, if I want to write the subduplicate ratio means take directly the square roots 1/2. And if it is subtriplicate means cubic root of x and y. So that means cubic root of root 2 is to cubic root of root 3. Cubic root of root 2 is to cubic root of root 3. Next, Reciprocal means what? See here students, generally, just now I told you, whenever we see P by Q forms, what we will do is, we will multiply it with them with their LCM, right? What is the LCM of A and B? Generally AB. AB, right? So I will multiply this with AB. When I multiply this with AB, this A will get cancelled, this B will get cancelled, and we will be left with what? B is to A. So directly you can interchange the values. 1 by A is to 1 by 2. For example, if I have 1 by 2 is to 1 by 3, then I can directly write the value as 3 is to 2. But if in case I have 3 values, that means 1 by A is to 1 by B is to 1 by C, then don't take it in a reverse order. You will get wrong. So in that cases, take the LCM of denominators and multiply them individually, and then only you will get the answer. What actually happens for if I have 1 by A is to 1 by B is to 1 by C means BC is to AC is to BC, AB. BC is to AC is to AB we will have if I have 3 ratios, 1 by A is to 1 by B is to 1 by C. Okay. Now inverse ratio means simply reverse it. What is the inverse ratio of x is to y? Means it becomes y is to x, y is to x, y is to x. So these are the some of the standard things which you should know before solving the problems or any other things. Okay, understood? Next. Okay. Now in this ratios concept only, we have a concept called joining of the ratios. So what we will do in case of joining of ratios, we should know how we will join the ratios. How we generally join the ratios means, see here, for example, if I have A is to B as some 2 is to 3, and similarly if I have some B is to C as some 3 is to 4. Now please observe here students, whenever I want to join two ratios, the first basic rule is definitely they should have a common element. That means here B and here B I have, so I can join this ratio and I can write A is to B is to C. Value is secondary, but to join the ratios, definitely I should have a common element. For example, if I have something like this, A is to B is equal to some 3 is to 4 and C is to D is equal to some 6 is to 7. I can never join these two ratios. The reason is I don't have a common element between these two things. Here I have AB, here I have CD, but I don't have a common thing, so I cannot write A is to B is to C is to D, which is impossible for me. So to join two ratios, definitely we should have a common relation between them. And now see here, what is B portion here? 3, and what is B portion here? 3. So both are same values, so directly I can take 2 is to 3 is to 4. If the common element contains the same portion here and here 3 parts and here it is also 3 parts, right? So I can join it directly. I can join the ratios directly. But if I have different values, something like this, A is to B is equal to 2 is to 3 and B is to C is equal to some 4 is to 5. B is to C is equal to some 4 is to 5. In this case, I cannot join the ratios directly. First of all, I should make sure that B values should be equal. That means see here, what I have here actually A is to B is equal to 2 is to 3, good, superb. And B is to C, what they given for me, 4 is to 5. What is B value here? 3, and what is B value here? 4. To equal these two values, what I will do is, I will multiply this 3 here and I will multiply this 4 here. Understood? I can multiply a constant to any ratio, right? By taking the advantage of that one, I will do this one. So 2 in, what happens to this? 4 2s are 8, 3 4s are 12. And next 3 4s are 12 and 3 5s are 15. Now if you observe carefully here, B value here is 12 parts and here it is also 12 parts. So now I can write A is to B is to C as 8 is to 12 is to 15. So before joining any two ratios, make sure that the common element value remains the same. If the common element value is same, then you can join them directly. Else you cannot join the ratios. And now sir, if this is the case, there is one more shortcut method for this one. Please observe this one. There are 3 elements for me, A, B and C. First of all, I want to clear you one thing, that I have not written them in the alphabetical order. I have written them in such a manner that the common element lies between them. Between A is to B is 2 is to 3 and B is to C is 4 is to 5. What is the common element for me here? B. Because of that reason I am writing B in the middle. Remember this one carefully, students. Okay, why I am writing B in the middle means not because in alphabetical order, the reason is B is common element between. For example, if I have A is to C and C is to B, then I would have written C in the middle. Understood? Now, A is to B, what it is? 2 is to 3. Okay, good, superb. Next, B is to C, what it is? 4 is to 5. 4 is to 5. And now I have two empty spaces here and here. So, fill these empty spaces with the adjacent value. So, this will be 3 will come here and this 4 will go here and multiply them simply. So, 2 4s are 8, 3 4s are 12, 3 5s are 15. So, the ratio between A is to B is to C is 8 is to 12 is to 15. Okay. So, this is the traditional method and this is the shortcut method. Why I have told you the shortcut method means, for example, if I have 4 components, something like this. Let me erase this and I will show this one. For example, if I have 4 components, A is to B as some 2 is to 3, B is to C as some 4 is to 5 and C is to D something like this 6 is to 7. 6 is to 7. Now, I want A is to B is to C is to D, or if the question is I want A is to D. How I can find this one means, if you observe carefully here, if I go with the traditional method, what happens is first I need to equal B's portion, next I will get ABC and next I need to equal C's portion and I will come ABCD. But if you know the shortcut method, A, B is common, B and C are common, right? B and C are the bridges between them and D at the last. A is to B, what they given for me? 2 is to 3. B is to C, what they have given for me here? 4 is to 5. And C is to D, what they have given me? 6 and 7, right? Now write all those things. Now where I have the empty spaces, here I have empty space here, here and I have 2 empty space here. Fill them with the adjacent values. For this there is no adjacent, so first fill this. So I will write 3 here and the same 3 will come here. So 5 will come here and 4 will go here. For this there is no adjacent, so first fill this one, 6 will come here and 6 will go here. So now please observe 2 4s are 12, 12 6 are 72. Meanwhile, if anything is cancelable, consider them as a team. If anything is cancelable, you can cancel it meanwhile. Or else, sir, why we need to make complicated means, first of all calculate them and then later also you can cancel it. There is no problem. Either you can cancel them as a team now itself, 3 here, 3 here, 3 here and 3 will get cancelled here. You can cancel that. Or else at last also you can do 2 4s are 8, 8 6 are 48, 3 4s are 12, 12 6 are 72, 3 5s are 15, 15 6 are 90. Next 3 5s are 15, 15 7s are 105. If you observe carefully, I can cancel everything with 3 table. 3 16s, 3 24s, 3 30s and 3 35s. Can I cancel them with any other number? No, I cannot cancel all of them with once again with any other common number. So 16 is to 24 is to 30 is to 35. And remember one more thing, students, if you want to write ABCD, you cannot cancel them with a common number, so you cannot. So don't say that, sir, I will cancel 16 and 24 with 4 table. It is not like that. You cannot cancel them if they are in the same group. For example, if the question is, what is the ratio between A is to C? A is to C. Now you can take them individually. So A is 16 parts and C is 30 parts, right? Now you can cancel it. Now you can cancel them. Why? Because you have only 2 components here in 2 table, 8 is to 15. I can write this as 8 is to 15. But if they are in the same ratio, you should not cancel it. Until and unless if they are completely cancelable. That means all the numbers are cancelable, then only cancel it. Else you cannot cancel them. Understood? If you take any 2 specific values, then take out them and then can cancel. Now see here 16 is to 35. A is to D means what? 16 is to 35. Can I cancel them? No, I cannot cancel them. Why? Because 16 and 35 are co-primes for me here. So we cannot do anything. We will write the same thing as A is to D. So in this manner, you need to join the ratios. While joining the ratios, 2 things you should keep in your mind. The first one is definitely there should be a common element, then only we can join them. And the second thing is, while joining the ratios, the common element value should be same. Then you can join them. Or else if you use the shortcut method, You need not to look about all those things. Directly simply follow the process and get the answer for you. And remember, the common element should be there in the middle. The common element should be there in the middle, right? Proportion. What we call, or which numbers we call in proportion. We see here, if you go to any photo studio, in general, what we will have on the board, we will have different sizes of photos, right, on the display. They will have different sizes. They will mention us the sizes in the below that. What they will say is 2 by 4. That means 2 inch into 3 inch or 2 centimeter into 4 centimeter. That will be the size of the photograph. And similarly, you will have something like this 4 by 8. 4 by 8, something like this. Different sizes he will mention on the display sheet. Now, if you observe carefully on that, the same element, right? The same size, whether it is on the same content will remain same. The same photograph, it will be changed from these dimensions to these dimensions. Take for example, our video only. Few people will watch it in mobile phone. Few people will watch it on the computer screen. So, the content remains the same. That means the value, whatever the portion which you can see on the screen with the total screen, it remains the same. But the alignment, it will change based on the view on which we are working. So, that means what I can say is, these two things are proportion to each other. Proportion means what it means, see here. If I further cancel it, it becomes what? 2:4 only, right? So, I can say that this is proportion with this one. Proportion means they are not physically equal, but by appearance they will be equal. Physical dimensions will not be equal, but they will be in the same proportion. That means length and breadth. Proportion will be there, right? That remains same. That remains same. So, such type of ratios we call them are in proportion. In proportion. In physical quantity they are not equal, but proportion wise they are equal. But proportion wise they are equal. So, we call them as proportional to each other. For example, if I say that if two ratios are in proportion, usually it will be indicated with this symbol. This symbol is nothing but the proportional symbol. Proportional symbol in other terms we call, in terms of ratios, we call it as equal. We call it as equal. So, what I will write here, A by B is equal to C by D. This proportionality symbol I can write this as equal to. Okay. When I write in this manner, what happens here for me? A into D is equal to B into C. A into D is equal to B into C. A into D is equal to B into C for me here. Okay, understood? So, the same thing I have written here. In general, ratios of A and B is equal to the ratio of C and D means proportion. Ratios, how the ratios can be equal? Ratios are not even the physical quantities. They are just the representation of a physical quantities. How they can become equal means nothing but they are in the same proportion. Okay. They is represented is with this symbol. Okay, 4 quantities and the first, second, third, fourth are terms respectively. The first and fourth are known as extremes. See, A and B are at the extreme ends, so we call them as extremes, and B and C we call them as means in general. Okay, the same thing, known as middle terms or means, and A is to B. So, therefore, what I can write, just now I have written, right, A into D is equal to B into C, AD is equal to BC, that the product of means is equal to product of extremes. Product of means is equal to product. Here D is called the fourth proportional and D is equal to. If I want to write D here, what I can do? I will send A to the other side. So, what happens to D value for me here? BC by A. D value becomes what for me here? BC by A. Okay, just a proportional symbol, nothing more than that. Okay, so what happens for us is in the examinations is in general, here there are 4 terms, right? A, B, C and D. Okay, here we call this A as first proportional, B as second proportional, C as third proportional, and D as fourth proportional. So, we will have different questions based on this. What is this first proportional, second proportional, third proportional and fourth proportional means? Based on the context, it will change. For example, they will ask a question, find the fourth proportional of 2, 3, 4. Find the fourth proportional of 2, 3, 4. That's it. They will not mention any other thing. So you should understand by default that 2 is the first, 3 is second, and 4 is the third one. 2 is the first, 3 is second, and this fourth is third, and we need to find the fourth proportion. That means how you will write means 2:3 is proportional with 4:A. We need to find that A. We know that product of extremes is equal to product of means. That means what I can write, or else if you don't know that concept also, 2/3 is equal to 4/A. 2/3 is equal to 4/A. So simply cross multiply it, what you will get here, 2 into A is equal to 3 into 4. 2 ones, 2 twos, so A value will become what, 6. So the fourth proportional for this is 6. Like this. In some questions they will say that find the third proportional of 2:3:4. 2, 3, 4. If they want you to find the third proportional of 2, 3, 4 means how you will write means indirectly he is mentioning that he skipped the third one. He skipped the third one. So what, how you will write equation, 2:3 proportional with A:4. Why? Because in question he clearly mentioned that he asked us to find the third proportional. Then you will write the equation in this manner, 2:3 proportional with A:4. A:4. That means in the place of third term I will put A. In the place of third term I will put A and I will calculate it, product of extremes. And similarly they may ask us what is the first proportional of 2, 3, 4. First proportional of 2, 3, 4 means what? Indirectly is skipped the first one. So directly what I will write, A:2 proportional with 3:4. A:2 proportional with 3:4. So based on the questions, we will shuffle the things. We will shuffle the things. Always they will give you the them in an order. So whatever the value which they ask you to find, they will skip that one value. That's it. Nothing more than that. And next in this one only, we will have one more proportion that is called as mean proportion. What is this mean proportion and in under which context we will come across that mean proportion means, see here, when they ask you about the mean proportion, usually proportion means usually how the ratios will be there means A:B proportional with B:C. A:B proportional with B:C. That means the middle terms will be equal. The middle terms will be equal. In this case, what we can say is B square is equal to AC, right? B square is equal to AC. So this B we called as mean proportion. So B value will become root over AC. This B is called as mean proportion. Okay, understood? Apart from this first, second, third and fourth, we will have one more proportion, that is mean proportion. Mean proportion is nothing but if the middle terms are equal, then how I can write my equation, A:B is proportional with B:C, then this B will be called as mean proportion. Product of extremes is equal to product of means. Now in general, how the question will be asked from this one is, what is the mean proportion of 4 and 9? What is the mean proportion of 4 and 9? That is the question. That means you should understand that the equation is something like this. 4 is proportional with A:9. 4 is to A is proportional with A:9. You should understand. Mean proportion means definitely the middle terms will be equal. So now what happens to this one? 4 into 9 is equal to A square. So A value will become what for me here? 6. A value becomes 6. So the mean proportion means nothing but the middle terms will be equal. In that case we call them as mean proportion. So now understood first proportion, second proportion, third proportion, fourth proportion and mean proportion, right? So these are the proportional based questions. Not only this, we will have some other cases where we will use these proportional relations and all those things. Okay, understood? Now we will move to the next one. The same thing, mean proportional. If three quantities A, B, C are in the continued proportion, then A:B is equal to B:C. Just now I told you, right? Instead of proportional. Therefore, AC is equal to B square. B is called the mean proportional. B is called the mean proportional for us here. B is called the mean proportional for us. The same thing we have written. Find X to complete the proportion. One of that questions. 2:5 is equal to 6:X. We know that product of means is equal to product of extremes. So what you will write? 2 into X is equal to 5 into 6. So 2 ones, 2 threes. So X value becomes what for me here? 15. And similarly here also product of means is equal to product of extremes. So 16 into 35, that is extremes, is equal to product of middle terms is 20 into x, 20 into x. 4 table, 4 4s are, 4 5s are, next 5 1s are, 5 7s are. So x value what I will get here? 28. So x value I will get here is 28. Okay, like this we are going to find the proportional values. Right, students? With this we have seen just the introduction of these ratios. What are the basic properties of ratios and what is the proportions and how we will find the proportionalities, that is first proportion, second and mean proportions, and what are the basic idea, what we can do to a ratio and what we should not do to a ratio. These are the things which we have learned in this session. In the next part we will start solving the problems and different questions from this area called ratio and proportions. Thank you.